Okay, here's a third example to dealing with analytic geometry of triangles. So it says find the circumcenter of triangle ABC, and then you're given points A, B, and C, coordinates for each point. So this is a good one to draw a little sketch, so you can kind of see what you're working with here. So very rough sketch. A -7, 3, B -2, 8, and C 2, 6. So the triangle is going to look something like this, and you're trying to find the circumcenter. So that means if you draw a circle that goes through all three of these points, let's pretend that that's a nice perfect circle. And then you find the perpendicular bisectors of each of these sides. So it goes through the midpoint of each side at a perpendicular angle. 1, 2, 3. Kind of like this. Somewhere around here, you're going to have the circumcenter. My sketch is really terrible, so I don't know whether it's inside the triangle. It might be outside. Regardless of what happens, it will be the same distance from each of the vertices of that triangle, and it will be the center of that circle that goes through all those points. So to find a circumcenter, you need to find the midpoint of the sides. You need to find the slope of each side, and then use that slope to get the perpendicular slope, and then get the perpendicular bisector of each side. So it has the perpendicular slope, the negative reciprocal, and it goes through the midpoint. So you need the perpendicular bisector of technically all three, but as long as you find two, where those two perpendicular bisectors intersect will be the circumcenter of this circle. So I'm going to pick two of the sides, so maybe AB and BC, find the perpendicular bisector, which has multiple steps to get there, and then find the point of intersection of those two perpendicular bisectors, and that will tell me where this circumcenter is. So let's say I'm going to use AB. So here's this blue line, perpendicular to side AB. And then let's say I use BC, find the perpendicular bisector here, and then wherever they happen to intersect, that will be my circumcenter. So I'm looking for the point of intersection of those two lines. Okay, so let's begin. So we need midpoint formula, we need slope, and we need to know how to get an equation of a line when we're given the slope and given a point on the line. All of this which we know already. Then once we have those two lines, we need to find the point of intersection of those. So we know how to do that already. So this is the type of question that's putting together all of the things that we've done in grade 9, but also in grade 10 geometry and analytic geometry and linear relations so far. Okay, so I'm going to start with side AB, and I'm going to find the midpoint of AB first. And again, lack of space here, so I'm not writing down my formulas, but you should always write them down at the beginning. So midpoint of AB, so you find the average of the x values and the average of the y values. So -7 plus -2 over 2, 3 plus 8 over 2. -7 plus -2 is -9 over 2. And 8 plus 3 is 11 over 2. So that's the midpoint of AB. Then I'm going to find the slope of side AB because I need the perpendicular slope. So 8 minus 3 over -2 minus -7. So that will give me 5 over 5, which is 1. So then the perpendicular slope, found that dead spot again. The perpendicular slope, so this is slope of AB, which means the perpendicular slope will be the negative reciprocal of that. So it becomes -1 over 1, which is -1. So then the perpendicular bisector, we know the equation of the line is y equals mx plus b. Apparently it's not going to let me right there. Y equals mx plus b. And then we know that this point, the midpoint AB, is on the line, and we know that it has the slope of -1. So I'm going to substitute in this information with this information. So 11/2 is equal to -1 times -9/2 plus b. So 11/2 is equal to positive 9/2 plus b. I'm going to bring the positive 9/2 to the other side. So I'll have 11/2 minus 9/2 is equal to b, which means that b is 11 minus 9 is 2. 2/2 is 1. So b equals 1, which means that the equation of this line is then really bad math form, but I'm going to write it over here. Y equals -1, so negative x plus b, which is 1. So we have this equation. And then for side, let's choose BC. Find the midpoint of BC. So the midpoint is 0, 7. And then the slope of BC (2 over -4). So if you reduce that to lowest terms, it's -1/2, which means that the perpendicular slope will be positive 2/1 or positive 2. So then we're going to take this and put it into the equation of a line. Y equals mx plus b. Y is 7, m is 2, x is 0. 2 times 0 is 0. So b is 7, which means that our equation is y equals 2x plus 7. Now, I don't have enough space, so I'm going to add another page here. So now I need the point of intersection of those two lines. So my first line was y equals -x plus 1. And my second line was y equals 2x plus 7. The y is already isolated in both, so I'm going to use substitution and sub equation 1 into number 2. And then I need to collect like terms. So I'll bring the 2x to the other side, so I'll get -3x. I'll bring the 1 to the other side, so I'll get 6, which means that x is -2. And I'll sub that back into one of the equations. Doesn't matter which one. First one looks nice and easy. -2 is 2, plus 1 is 3, which means the point of intersection is -2, 3, which actually means the circumcenter is that point. -2, 3. Now, I want to point out that right here, I put a Desmos link. So I'm going to show you what that is. This one's quite complicated, so I put it into Desmos. So in the first folder here is the points ABC, and you can see them all here. Then I did the lines that make it a triangle, and I use these squiggly brackets to cut the lines off so they don't go on and on forever. So there's our triangle ABC, which kind of sort of looks like that little sketch that I made. There's the midpoints of all three sides. We calculated D and E. I call them D, E, and F here. It doesn't matter. We calculated midpoint of AB, and we calculated the midpoint of BC in the Jamboard just before this. I also calculated F here. And then the next folder has all three perpendicular bisectors. So the orange one and the green one that go through D and E are the ones that we just worked with. And then the purple one is the perpendicular bisector of side AC, which we didn't calculate, but this way it shows you that the circumcenter here is where all three of these perpendicular bisectors intersect. So using two of the sides would not matter which two. No matter what you do, you'll get that same circumcenter. So the link is there, so you can play with this a little bit, and you'll be able to add and remove things and see where all of these equations and where all of these points came from.